To find the partial sum, you have to add each term of the sequence together. So the first one is just 1/2. For the second one, you're going to add the first two terms together. 1/2 plus 1/4 is 3/4. For the third one, you're going to add all three of these together. You're going to get 7/8. For the fourth sum, you're going to add all four of these together and you'll get 15/16. What is the next number in this series? Yes, 1/32. So if you add all five of these together, you'll get 31/32. And then the next number in the sequence? Yes, and if you add up all six of these, you'll get 63/64. Now, guys, go ahead and give me the decimal for all of these. Can you guys give me the decimal for these? 0.5, 0.75. Okay, 75, thank you. Next one. 93.75. Okay, next one. Thank you. Last one. Very good. Okay, so guys, do you see how the numerator is just one number less than the denominator? So one day, if you keep going, you're going to have, for example, 1,000 over what? 1,001. Put that in your calculator. What would that be? Point what? 999,001. Do you guys see what number this is approaching? It's getting closer and closer to 1. The more numbers you add up in this series, you get closer to 1. Do you guys see that? We're going to say that this is converging to 1. It's getting closer and closer to 1. The more numbers you add up, you get closer to 1. Okay? Let's look at this table over here. This was 1/2. This was 1/2 plus 1 is 3/2. If you add up these three terms, what will you get? 7/2, which is 3.5. And if you add up these four numbers, what will you get? 15/2, which is 7.5. And then if you add up these numbers, what will you get? 31/2, which is 15.5. And what's the next term after this? 16, because it's multiplying by 2 each time. If you add up all those, what will you get? 63/2, which is what? No. Is it 31.5? Okay. There we go. Okay, so guys, what's happening to these numbers? Does it converge to a certain number? It's just getting bigger and bigger, right? Okay, so this is called diverging. It's not going to a single number like we did here. So this one is called diverging. It's divergent because it's diverging. Okay, so let's talk about the ratios for each of these. I'm going to clean this up a bit. Let's talk about the ratio. So how do I figure out what the ratio is? Do you guys remember? Exactly. The second term divided by the first term. So 1/4 divided by 1/2 is what? 1/2. Okay, next we'll do 1/8 divided by 1/4. And you get 1/2. So guys, here your ratio is 1/2. Okay, tell me what the ratio is here. What's 1 divided by 1/2? It's 2. Now let's do these two numbers. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. Oh, this should be a 2. Okay, so guys, what did I get every time? 2. So that means my ratio here is 2. Guys, when your ratio is bigger than 1, it's divergent. When your R value is less than 1, it's convergent. So let's write that down. When your R value, we're going to do the absolute value. It doesn't matter if it's negative or positive. If your R value, the absolute value of it, is less than 1, then the series is going to converge. It's convergent. It's going to go to a single number. If the absolute value of your R value is greater than 1, then it will diverge. It's divergent. So notice in our very first example with this first table, our R value was 1/2. So all of these numbers were getting closer and closer to 1 the more we went on. Here, our R value was 2. So as we continued with our series, adding them all together, it just got bigger and bigger. It didn't go to just one number. So let's look at some examples. Oh, before we look at an example, let me give you guys the formula. So instead of taking a long time to add every single number together, here's the formula. Okay, and this is the formula for a convergent infinite geometric series. Geometric series, so we know we're going to have an R for ratio. It's going to have a ratio, which is right here. And it's convergent. So guys, for our very first example, instead of adding up every single number to figure out these values, I'm giving you a formula for that. This is your formula. So let's look at an example. Let's say I have negative 180 plus 90 plus negative 45 plus 22.5. Okay, so I have a series here. Let's go ahead and figure out what the ratio is. We're going to do 90 divided by negative 180. That's negative 1/2. Negative 45 divided by 90, that's also negative 1/2. And 22.5 divided by negative 45 is also negative 1/2. So my ratio is negative 1/2. Now, if I want to figure out what number is it going to get closer and closer to as I add up every number, I'll use this formula up here. So to find the sum, you do the first term, which is right here, negative 180. 1 over 1 minus, and we just found out the R value is negative 1/2. So if you plug that into your calculator, you will get negative 120. And guys, the only reason I was able to use this formula is because it's convergent. How do we know it's convergent? Yes, because the absolute value of this ratio is less than 1. All right, guys, looking at this, which one is my R value? Yep, this is your ratio. That's your R value. So guys, what's the absolute value of negative 7 over 6? Is that bigger or less than 1? Bigger. It's larger. That means this is divergent. So you cannot calculate the sum. It's just going to go on forever. It doesn't converge to a single number. This is absolute value. So the absolute value makes this a positive 7 over 6, and that's bigger than 1. So your answer here is just divergent. You cannot use this formula. This formula cannot be used. This formula is only used when it's converging. If it's converging, you can figure out what sum or what number it's converging to. Okay, so this is just a review of what we learned the very first day of this whole unit. So just a refresher when you get to this problem on the test review. The very first term is a -4. We want to figure out what the other terms are. So let's go ahead and find the second term. If I want to find the second term, I'm going to use the rule that they gave me and replace the n value with a 2. That 2 stands for the second term. So I know the second term is -3 times, what's 2 minus 1? 1. Okay, so now guys, look at the information they provided us. They said that A1 is -4. So we're going to continue substituting. Instead of A1, I'm going to put in a -4. So this becomes 12 plus 7, which is 19. So that means the second term is 19. Now I can find the third term. So let's figure out what the third term is. To find the third term, we're going to plug in 3's. Okay, so let's plug in 3's this time. 3 here, 3 here. So that means this will become 3 minus 1 is what? 2. So now I want A2. Well, we just said A2 is 19. So that will go right here. So calculate what A of 3 would be. Negative what? -50. Thank you. There we go. So these type of sequences, you have to use the term before it and plug that in.